यह शोध पत्र 14 दिसंबर 2012 को वेटरनरी फार्माकोलॉजी एवं टॉक्सिकोलॉजी की 12वीं वार्षिक कॉन्फ्रेंस में पशु चिकित्सा विज्ञान महाविद्यालय बंगलोर में पढ़ा गया। यह शोध पत्र कुछ और भी अधिवेशनों में प्रस्तुत किया गया। शोध पत्र में वर्णित खोज के लिए प्रोफेसर डॉक्टर गोविंद पांडे को कई राष्ट्रीय व अंतर्राष्ट्रीय पुरस्कार मिले हैं। डॉक्टरेट डिग्री में किए गए इस शोध कार्य के लिए डॉक्टर गोविंद पांडे को श्री रामलाल अग्रवाल नेशनल अवार्ड से भी विभूषित किया जा चुका है। इस शोध पत्र में मुख्य खोज यह बतलाई गई है कि शकरकंद वो दुनिया भर में करोड़ों लोगों द्वारा खाया जाता है तथा हिंदू धर्म में उपवास रखने पर भी खाया जाता है। तो शकरकंद में जो काले धब्बे और निशान होते हैं उसमें आइपोमीमेरोन नामक टॉक्सिन अर्थात जहर उत्पन्न हो जाता है, जिसके कारण यकृत यानी लीवर खराब हो जाता है और अधिक मात्रा में खाने से मृत्यु तक हो सकती है। इसलिए शकरकंद के अच्छे भाग को खाना चाहिए। भारतवर्ष में अपनी तरह की यह पहली खोज है जो वर्ष 1988 से 90 में की गई थी। इंट्रोडक्शन: स्वीट पोटैटो प्लांट आइपोमिया बटाटास is widely cultivated and consumed throughout the world. Sweet potato tubers are edible and largely eaten by the Indian Hindu families during festival fasting. These are also used as cattle feed and for the preparation of starch. Sweet potato tubers are given in constipation, burning sensation, renal and vesical calculi, diabetes, general weakness, and as aphrodisiac. They also possess anti-hypertensive, antimicrobial, anti-inflammatory, antioxidant, and chemopreventive activities. Ipomyrmeron (IPM) is a 3 or beta substituted furan of sesquiterpenes group of phytoalexins. It is a toxic metabolite of sweet potato tuber. Japanese and American workers isolated IPM from sweet potato tubers injured by fungi, insects, and chemicals. Pandey 1990 and 2008. Wilson 1973, Wilson et al. 1978. Japanese workers prior to the World War II noted the toxicity of moldy sweet potatoes. Cattle consuming toxic tubers may show various respiratory and hepatic symptoms leading to death. Wilson et al. 1978. Aims and importance. The present study was carried out to assess the depth and severity of hepatotoxicity caused by IPM in rats. This study may occupy great importance to prevent the development of IPM by scientific cultivation, harvesting, and storage of sweet potato tubers. Materials and methods. Isolation of ipomyrmeron. IPM was produced in injured sweet potato tubers and isolated as per the method of Uritani et al. 1960 with slight modifications done by Pandey 90. To damage the tubers, their healthy slices, figure 1a, were treated with 1% mercury chloride solution containing 5% sodium chloride. Sweet potato tuber slices which were not treated with mercury chloride did not show positive Ehrlich reagent reaction, figure 1b. Analysis and extraction of IPM. Injured sweet potato tuber slices were tested with Ehrlich reagent, figure 1d and 2 lower slices. Slices which showed positive Ehrlich reaction, that is a pink color, figure 1c and 2 upper slice, were dried, powdered, and subjected to solvent ether, diethyl ether extraction. Ether extract was washed with 5% sodium bicarbonate, 5% sodium hydroxide, and distilled water respectively. Extract so obtained was dried with dehydrated sodium sulfate and finally evaporated to oily substance as a crude IPM, which was then subjected to steam distillation. The distillate was extracted with ether once again and dried with dehydrated sodium sulfate to yield yellow oil as IPM. Results and discussion. Isolation of IPM. Surface of injured sweet potato tuber slices deteriorated dead and appeared soft white after 3 days of mercury chloride treatment, and lining part between dead and adjacent normal tissues turned brown, figure 1c, brown. Margin part that involved IPM showed pink color with early reagent, figure 1d. In some injured slices, the inner tissues were damaged and had dark brown color with rare white patches, figure 2, upper slice. Brown dead tissues and also adjacent inner sound tissues normal turned pink with early region, figure 2, lower slices. Similar results were found by Uritani et al. 1960. Ether extraction and steam distillation of injured sweet potato tubers powder yielded dark brown oily substance called crude IPM, which has been reported as hepatotoxic in animals. Pandey 1990 and 2008, Wilson 1973. Hepatotoxicity by IPM after 48 hours of administration. Liver sections of rats administered with IPM after 1 month of isolation at the rate of 125, 250 and 500 mg per kg orally showed varying degree of congestion, degeneration and necrosis. Vascular congestion was seen at periportal to central and mid zones of liver lobule. Sinusoids were dilated and localized areas of necrosis were seen. Nuclei and Cooper's cells were not conspicuous, suggestive of karyorrhexis and karyolysis. Proliferation of connective tissues in the wall of biliary passages was intense, due to which the epithelial lining was undefined, figure 3. However, the hepatic changes were less prominent after administration of 4 months of isolation of IPM at the rate of 250 and 500 mg per kg, figure 4. The least changes in the hepatic tissues were seen after administration of 8 months of isolation of IPM at the rate of 500 and 1000 mg per kg, figure 5. Results of IPM indicate that IPM is an unstable compound and loses its hepatotoxic potency with lapse of time after its isolation. Conclusion: oral administration of IPM damaged the liver within 48 hours. Liver tissues showed varying degree of congestion, degeneration and necrosis. The hepatotoxicity was characterized by periportal, centilobular or mid-zonal necrosis. The extent and severity of liver damage appeared to be dose-dependent with duration of IPM isolation. The oral hepatotoxic dose of IPM after 1 month of isolation causing standard liver damage was determined to be 250 mg per kg orally in rat.